Hi guys, so I find the problem 1530, number of good leaves node pair. Okay, so this question is saying like, let me give you the brief introduction. Okay, suppose I have some nodes like this. Suppose this is the binary tree, okay, and I have the root. Okay, so and there is a distance. Let's say it be 3. Okay, so what this question is saying is, from any leaf node, if I can move to any other leaf node with the distance of 3 or less than that, then I have to plus 1. Means I have to find the number of pairs that are being formed, like this and this. Okay, so, but like suppose this is 2 and this is 3. So you will say like there are 2 nodes, so 2 and 3 will be one pair. And from 3 to 2 node, you will have another node, another pair. But we can't give this as an answer. We have to either choose this or this. So basically we can only choose any 2 nodes only for time. Okay, understood. So how can we solve this? Okay, and this is a binary tree. And if I want to iterate from the leaf node back to the parent and then parent some other leaf node, it is not possible in a tree, because in tree you can either move down, okay, like this, or from down to up with recursion. But you cannot jiggle path something in a tree. You can only do this in a graph. Or if I can jiggle path with one thing, like if I know the parent of this node, means a bidirectional binary tree. It means like if I have a node, then I know its left and right. But in a data structure, I will store a parent too. Okay, so that I can iterate like this. Like I can iterate like this, or I can iterate like this. And I have to find the shortest path. Okay. So how can we solve this? First, find the parent node in a data structure. Okay, let's store this. Okay. Second, find all the leaf nodes. Find all the leaf nodes. Third, just like graph iteration, traverse with steps. Like I can only do 3 steps. Okay. So let's code this up. Let's make find parent. Second, find all leaf node. Then traverse the tree as a graph. Okay. So let's find the parent. I can store the parent in a hash map where key would be a tree node and the value would also be a tree node. Okay, let's find this. So I will do like, let's do the DFS. Find parent. If not node is simply written, or if node dot left, then parent node dot left equals to node, and if node dot right, then parent should be node dot right parent should be node. Okay, so this is adding and simply call find parent for the node dot left and find parent for node dot right. Okay, okay. So I have find the parents. So let's call this function find parent for. Okay, now I have a data structure which store the parent of a node. Like if I have a key 2, then it should indicate to 3 as a value. Okay, now find all the leaf nodes. Okay, def dfs. It should be no. Okay, simple like add space. If not no, then return. Okay, if so, how can I classify which node is a leaf node and which is not? So basically, what is like if I have two nodes, if if a node have either left or right means it is in the mid of the tree, and if the left and the right node is null, then it's a leaf node. So if not node dot left and not node dot right, then it's a leaf node. It's a leaf node. So for that, I will call function. So let's keep this aside or till then else dfs node dot left and dfs dot right. Okay, let's call this function. Now, if I got a leaf node, then I have to iterate from this node to rest of the path, rest of the graphs, but with the steps. Like I can only put 3 steps, like 1, 2, 3. If there is another node like here, then I cannot go further. Okay, so let's make a function def. I will go like the function name dfs graph. Okay, and in this I have node comma steps that are left by tree. So let's copy this and paste this, and I need distance here. Okay, so this is done. Now let's code for how to traverse the graph. Like if not node or my steps are less than 0, then return. Okay, I just simply move the function. Now I need a visit also, like I said, like which node I have visited. So that like if I go from 4 to 2, that I should not go from 2 to 4 again. Okay, so it will be a set. Okay, or node and visit. Then I simply return it. Okay, or now let's add the node in the visit. Like I have visited this node. I have visited this node. Okay, now how to iterate? Now, from one thing is if I found another leaf node or I am at any node. Okay, now how will I check that this node is a leaf, another leaf node? Same this, but if I am standing here, this is also a leaf node. So it will always move to this if. So for this, I am being little clever and I will like the step should not be equal to the distance, because if I'm standing here, then my steps are not used. So n steps not equal to distance. Then what I have to do is I should be like, this is restored my result. Let's return this result and press 1. But I have to use non-local here because this is not a local variable. This is someone like parents variable. Okay, now press 1. And if I'm standing here, then I should return. Okay, so if I'm standing here, then I should increase the count and return. Else, what I will do is I will just iterate. Like if I'm going here, let's go for the parent. Or if I'm standing here, let's go for the child. So let's go for the child. If like DFS graph node dot left and node dot right, and if node in parent, then I will like parent and I will just simply copy this, paste here, and I should reduce a step. Okay, this is the code. Let's try to run this. There's some error. Yeah. Now, I am saying that let's clear this shit. Now, if I'm standing here, then I can go to this position. Okay, so this is +1. But if I'm standing here and I will move like this, it is also +1. So I'm getting 2 count instead of 1. I only need 1 count, so I will just divide the rest with 2 because I'm always counting 2 times the same pair. Now it's been accepted. Let's try to submit this. Perfect. It's been submitted. Let's analyze complexity if this is good. Perfect. This is n square. So how this is time complexity of n. Okay. And for every leaf node, I'm iterating the graph. So it is n square. Means n this into n. So n square. And for this, it is plus n. So n square plus n. Okay. And space complexity is around n. Yeah, perfect. Okay. Hope you understand this concept, and this is not a easy or a medium portion. To be honest, it is higher than the medium because the trick is how should we iterate from leaf node to the parent, then another child. We cannot do this with simple DFS or BFS. Okay, for that we need some more concepts. So that's why we have to make this into a graph-like structure, like the parent one, and iterate over it. So it is basically a smaller version of graph. Okay. So hope you understand this concept, and if you do, just give it a like and subscribe. And hope I'll see you in the next video. Till then, bye bye.